Example 2 is similar to example 1, except this time we're finding the exact value, which means no decimals, of tangent 22.5. And they tell us which of the 3 tangent identities they want us to use. Again, that goes back to the form of the answer so that we get the right form and there's only one right answer. So 22.5 is half of an angle that's special. If you multiply 22.5 times 2, then you get 45. So I don't want to multiply it by 2 because I don't have an equation to do the same thing to the other side. So I just want to think of 22.5. I want to rewrite it as 45 divided by 2. And since this is a half angle right here, then it matches this side of the identity, and I can rewrite that as sine of A. A over 2 is 45 over 2, so A is 45. So I have sine 45 degrees over 1 plus cosine 45 degrees. So it's half the angle here, it's the full angle over here. Now that we have special angles over here, we can substitute values for them. When we evaluate sine 45 using our hand trick, we see that that's square root of 2 over 2. And in the denominator, we have a 1 plus, and cosine 45 degrees is the square root of 2 over 2 as well. So we've left the trig behind. When we substitute our values, we have only numbers right here. This time we have a complex fraction with a baby fraction in the top, a baby fraction in the bottom. You can get rid of the complex part of the fraction by multiplying top and bottom of the big fraction by the baby denominators. Both these denominators are 2, so if I multiply the big fraction by 2 over 2, that will clear both of them. 2 times this fraction right here, the denominators are going to cancel. The denominator cancels with that 2 and leaves a square root of 2 on the top. On the bottom, I have to distribute the 2 through both of these terms, so 2 times 1 is 2, and then 2 times this fraction gives me the square root of 2. Now I need to rationalize this because I have the radical in the denominator, but since there are 2 terms in the denominator, to rationalize that, I need to multiply top and bottom of the fraction by the conjugate of that denominator. 2 plus the square root of 2 has a conjugate of 2 minus the square root of 2. If I multiply the denominator by that, I have to multiply the numerator by that as well. So let's distribute in the numerator, 2 times the square root of 2 for the first term, and the square root of 2 times the square root of 2 is just 2. In the denominator, conjugates gives me the difference of squares in factored form. So I'm not going to have a middle term. I'm only going to have two terms. The first one is comes from squaring the first number, so 2 squared is 4. The next term comes from squaring the square root of 2, which is 2, and it's the difference of squares, so I want a minus in between there. Now we can simplify that because 4 minus 2 is 2, and notice that each term of the numerator has a factor of 2, and I have a factor of 2 in the denominator. So if I factor out the 2 in the numerator, it leaves square root of 2 minus 1, and then divided by 2, and we can reduce those 2's that are factors, top and bottom, and that gives us a final answer of the square root of 2 minus 1.